Hello everyone. Let's begin with an introduction to material composition testing. This type of testing is fundamental in quality assurance and product validation. It allows us to determine the exact elemental makeup of a material, whether it's a metal, polymer, or composite. This is crucial for confirming if a material meets specific engineering and safety standards. It's not just about knowing what's in a material, but ensuring the material behaves as expected in real-world applications. For instance, in the automotive or aerospace sectors, even a slight deviation in material composition can lead to failure or inefficiency. That's why this testing is so widely used across industries like defense, energy, and electronics, to ensure reliability, durability, and safety. Let's look at why material composition testing is so important. It verifies whether materials used in production meet the required specifications, ensuring safety, quality, and consistency across every batch. We also introduce the Material Test Certificate, or MTC, a document that manufacturers provide to confirm the chemical and mechanical properties of a material. It's essentially proof that the material complies with global standards like ASTM, ISO, or EN. Material test certificates are essential across industries where safety, performance, and compliance are critical. For example, in the automotive and aerospace sectors, even a small material deviation can lead to serious failures. Medical devices and consumer electronics need strict verification to ensure safety and reliability. Industrial equipment, marine applications, and energy sectors all depend on material certification to avoid breakdowns, ensure durability, and meet global regulations. Before we dive deeper, here's a quick overview of the major methods used in material composition testing. These include optical emission spectroscopy, X-ray fluorescence, energy dispersive X-ray spectroscopy, inductively coupled plasma, combustion analysis, wet chemistry. We'll now look at each of these methods in detail, including how they work, where they're used, and what advantages they offer. This slide covers optical emission spectroscopy, or OES, a widely used method for identifying the elemental composition of metallic samples. Here's how it works. A high-energy spark is generated between an electrode and the sample. This spark excites atoms in the metal, and they emit light at characteristic wavelengths. A spectrometer captures this light, and specialized software calculates which elements are present and in what concentration. What makes OES valuable is its high accuracy and repeatability. It can detect a wide range of elements, especially carbon, sulfur, phosphorus, and others, in both ferrous and non-ferrous alloys. It's important to note that it requires a clean, flat surface on the sample to work properly. This method is highly used in steel manufacturing, foundries, and for verifying materials as per mill test certificates. To the right, you can see a typical OES test setup, where a technician is analysing a sample using the machine. This one's about XRF, X-ray fluorescence. It's a super handy, non-destructive way to check what elements are present in a material. Basically, it uses X-rays to excite atoms in the sample. Those atoms then give off their own X-rays, which are unique to each element, and that's how we identify them. There are two types: EDXRF, fast and portable, great for field use; WDXRF, more precise, usually used in labs. You'll see this used in metal alloy checks, mining, electronics like RoHS compliance, and even in geological testing. What's great is it's quick, doesn't damage the sample, and some versions are handheld, so you can test on-site with almost no prep. Now we have EDS or EDX, which is short for Energy Dispersive X-ray Spectroscopy. This one's usually paired with electron microscopes like SEM. Instead of X-rays, it uses an electron beam to hit the sample. That makes atoms emit X-rays, and by analysing those, we figure out what elements are in the material. It's super useful for tiny regions, like detecting contamination or checking small features in electronics and metallurgy. It's also non-destructive, fast, and gives great detail, especially on surfaces or particles. This slide covers inductively coupled plasma, or ICP, one of the most sensitive techniques for detecting trace elements. Here's how it works. The sample, usually in liquid or digested solid form, is injected into a plasma torch. You can see the torch setup in the image here. The high-temperature plasma excites the atoms, making them emit light or form ions. Now, based on what detector we use, if it's ICP OES, we measure the emitted light. If it's ICP MS, we measure ions, and it goes down to ultra-trace level detection. This method is perfect for metal purity, water-soil testing, pharma, and even semiconductors. What's great about ICP is it's super accurate, handles multiple elements at once, and works even with complex samples. This one is about combustion analysis, which is mainly used to measure carbon, sulfur, nitrogen and hydrogen, especially in metals and alloys. The process is pretty straightforward. We burn the sample in oxygen at high temperature. The elements convert into gases like CO2, SO2, N2 and H2O. These gases are then measured using infrared and thermal conductivity detectors. If you look at the image, that's a combustion analyzer. The furnace inside is where the burning happens. This method is widely used in steel, cast iron, copper, and even powder quality control. What makes it great? It's highly accurate for these light elements, gives quick results, and works well even for solid samples, which is why it's essential in metallurgy and foundries. Now let's move on to wet chemistry, also known as classical chemical analysis. Unlike combustion methods, here we dissolve the sample and then add specific chemical reagents. These reactions can lead to colour changes, precipitates, or titration endpoints, which we then measure, either manually or with instruments. This technique is great for detecting trace elements and is often used to verify or cross-check results from more advanced instruments. It's a cost-effective method, especially for elements that are tricky to detect with machines. So it's still widely used in labs for routine checks and complex analysis. Now let's talk about how to choose the right material testing method. The choice depends on a few key factors, like which elements you're testing, the accuracy you need, the sample type, and whether or not the test can be destructive. For light elements like carbon or nitrogen, combustion analysis or ICP is the way to go. But for general metals and alloys, OES, XRF or EDS are more than enough. If you need trace-level precision, ICP or WD-XRF are ideal. But for quick composition checks, XRF or OES work well and are more efficient. Need to keep the sample intact? Use XRF or EDS. For more in-depth lab analysis, ICP or OES may slightly damage the sample, but give better detail. Also, choose based on the sample form. Solids are good for OES and XRF, while ICP handles liquids, powders, and mixed materials. Finally, if time or cost is a factor, handheld XRF gives fast results. But for accuracy, lab-based ICP and OES are worth the time. Let's quickly compare the key testing methods for material composition. Each method here differs in terms of accuracy, cost, speed, and whether it's destructive or not, which helps us decide which one to use depending on the application. OES offers high accuracy, used mainly for metal alloys and quality control. XRF, non-destructive and very fast, ideal for field use like row checks and scrap sorting. EDS, good for surface analysis in small or coated samples, commonly used in SEM labs. ICP, very high accuracy, best for trace elements in liquids and solids, though it's destructive and costly. Combustion Analysis specifically targets C, S, N, H in metals, with fast and reliable results. Wet Chemistry, suited for non-metals or complex samples, still useful where advanced instruments aren't ideal. So the choice depends on your sample type, required accuracy, and whether you need fast or lab-grade results. There are various standards based on which each test is performed, mainly from ASTM, ISO, and EPA. These ensure consistency, accuracy, and global acceptance of results. For OES, standards like ASTM E415 are used to analyze carbon and alloy steels, ideal for clean, flat metal surfaces. XRF testing follows ISO and RoHS-related standards, great for metals, plastics, and environmental samples. EDS-EDX aligns with ASTM and ISO standards and is mainly used with SEM for micro-area surface analysis. ICP uses EPA and ISO guidelines to detect trace elements in water, metals, and soils with high sensitivity. Combustion analysis standards help measure carbon, sulfur, nitrogen, and hydrogen in steels and alloys. And wet chemistry is supported by classic standards for titration and gravimetric methods, especially useful when instruments fall short. So, selecting the right method also means adhering to the right standards, ensuring both technical reliability and regulatory compliance. So what do we really offer at November Services? Well, it's more than just testing. We help you make sure your materials and products are safe, compliant, and ready for the market. We perform material composition testing using trusted methods like OES, XRF, ICP, EDS, and combustion analysis, all aligned with major standards like ASTM, ISO, and BIS. But it doesn't stop there. We also offer consulting support to help you choose the right tests, engineering and product development services, and even traceability and certification to meet customer or regulatory needs. Whether you're in automotive, EV, aerospace, or heavy manufacturing, we've got the tools and the team to help you validate your raw materials and final products, with clear insights and reports that make your job easier. Thanks so much for your time and attention. It's been a pleasure walking you through what we do at November Services. We're all about reliable, accurate, and standards-driven material testing backed by a solid team of experts ready to support you, whether it's for compliance, certification, or just better decision-making. If you've got any questions, want to book a test, or simply need advice, feel free to reach out. We're just a call or email away. Looking forward to working together and helping you take your materials and products to the next level.